Welcome to this afternoon. I'm Brian Spanolini. I'm the Exadata Cloud Service Project Manager, and I also have Sebastian Solbach with me, and he is another Exadata Cloud Service Product Manager or Development Lead. He can clarify that later. But we actually are lucky to have an actual customer with us. We have Jeffrey Chouet with us today, who's from OceanX, and I'm going to be handing off to him in 1 second. But first, let's go quickly over the agenda for what you're in for today. First, we're going to talk about Exadata Cloud Service in OCI, customer experience, what's it like, and Jeffrey will tell you all about it. Next, we're going to actually go through what this presentation's about, which is the do's and don'ts. Then we're going to go to the runtime do's and don'ts, which are a little bit different, but again, we'll talk about what you can and can't do with the Exadata Cloud Service. Next, we're going to talk about the APIs, what API CLIs we have into the service. If you've been to any of the OCI presentations or any other product presentations, a cloud is all about APIs. So we'll talk about what they have. And then lastly, a little bit on futures. Now, Safe Harbor, we will be talking about futures. Please don't plan any purchases upon what I'm going to say because they may or may not come true. And if you approach me with them later, I will flatly deny I said any of it. So with that, let me hand it over to Jeffrey, and we will go into customer experience. Thank you. Jeffrey?
Thank you, Brian. Hello, everyone. My name is Jeffrey. I'm from OceanX. So really quickly, OceanX is it's a new company that was spun off from Gatiranker. So we specialize on enabling membership economies for company who wants to sell directly to consumers without retailers. And we're helping them to establish the relationship with the customers to have recurring revenues through memberships. So even though it's only 2.5 years that we have a lot of experience doing that by being part of the Gatiranker family, which has been doing that for more than 25 years. So within that, our platform, basically, we provide a platform to enable the customers to utilize our services, to have one-stop shop, to provide the e-commerce, to have the fulfillment services, customer cares, as well as the business intelligence available to the customers. And we partner with brands to launch, to grow, and to scale the recurring revenues. Right. Within our core features, BI, business intelligence, is the cream of the top of the service that we provide. So currently, we have data points from various data points, including from order processing to order entries to fulfillment to financings to customer service like online customer service interactions. And we also provide integrations, both internal and external. And on top of that, we have reportings, KPIs, we have dashboards, we have self-service analytics. And we're also working on more advanced analytics, including the real-time data streamings, LTV predictions, so on and so forth. So with all these data tuning, data processing, we need a very strong, solid, performing platform. So at OceanX, actually, we are early adopter of clouds. So we migrate all our on-premise data center to a colo company called Savis, and later on being part of the CenturyLink 4 years ago. And then in 2017, we migrate everything from CenturyLink into AWS. So we were having high hopes with AWS, with all the features that we provide, and also the cost savings that we can realize. Mostly they're good, except one piece, database, right? So we run Oracle for most of our internal processings, and especially for business intelligence. So we have about 15 terabytes of production data that we process. We crunch out reports, cubes for customers. So after we migrate to AWS, we realized the performance are not there. it's just slow compared to what we had in CenturyLink. CenturyLink is kind of old technology already, right? AWS, you think you're getting the Cadillac of the cloud, but it's not the case, unfortunately. So the ETL process has been constantly slowed to a point that usually we can deliver the reports by 8 o'clock in the morning. Now we have to wait until 2 p.m., 3 p.m., sometimes by 6 p.m. the report is not ready yet. So that's a big impact to our deliverables, to our SLAs, to our customers. So then we engaged AWS technical team to see how they can help us, right? So yeah, they came out with architects, engineers, and we tried different things. At the end, they conceded the only thing we can do to achieve what the performance we needed is to scale up the VM instances. Meaning if we had an instance for 16 virtual cores, we have to go up to 32 virtual cores, or even more, to get the performance that can be acceptable, right? And we tried that, and yes, it did increase that performance to a degree that we can accept, not as good as before, but by doing that, that will put us into a big compliance issue with the licenses with Oracle. So that's a big challenge that we had, right? So at the time, we approached Oracle. Oracle, actually, we have been watching Oracle Cloud for a couple of years when we were even considering AWS. At the time, in 2016, I don't think Oracle Cloud was quite ready yet. There are a few contentious concern that we had is that because we have a lot of core applications and systems that we will still use in AWS, if we move our BI platform databases into Oracle Cloud, how we connect these two clouds together, right? At the 2016, Oracle doesn't have a good solution yet. And 2017, when we had issue, when we reached out again, they had a solution with the Equinix, through a third-party vendor Equinix, with the megaports. So we did extensive POC with them. So we ran the full loads from beginning to end for ETLs to the real-time data pools to the reportings and dashboards and cubes. And to our surprise, the performance actually was very good. As you can see from the chart that we can get up to 6 times faster compared to what we are seeing in AWS. So that was very, very encouraging, right? And at the same time, we got very aggressive pricing from Oracle, that the cost actually is much cheaper than what we are currently paying, or at that time that we were paying to AWS. So that almost is like a no-brainer, right? So even with that Equinix and Megaport, there's still a few concerns of the latencies between the two clouds. Anytime you have hybrid clouds, when you have running from AWS in Portland to OCI in Phoenix, there's that average about 40 milliseconds latencies. So we had to do some tunings or internal refactorings to make sure that we do not have that compounded by unnecessary round trips, right? So for the ETL processes, we had to change the commit size from the default 10,000 up to 50,000. For Java applications, we had to change the way that we pull the data. It used to be like for each screen, we run 100 queries to get each row to be displayed on the screen. Now we do one call for 100 rows and do another call to combine the data into the result sets. So that would cut down from 101 calls to 2 calls. So that end up to have very comparable performance for applications, but for ETL, it's actually even faster. So this is a high-level diagram that what we have deployed in OCI, as well as the interaction between the AWS to OCI. What we decided to use is 2 quarter rack for the Exadata, both in Phoenix, one for production stage, the others for QA and dev. And we do have a DR site in the Ashburn, Virginia, but we're using the VM instance for that to cut down some costs on that. And we have the Megaport communicating between the AWS and OCI. So one thing that we found out during the process is Oracle is constantly working on improvements or working with new vendors with new approaches, right? So when we did the POC, we were going through Equinix, but when we did the deployment, just before the deployment, we didn't have to go through Equinix. So Megaport came out with a direct connection between those two clouds that allow us to cut down one extra hop. Actually, will made the performance even better. So OceanX, as I mentioned earlier, we did multiple migrations through different service providers along the years. And for this migration from AWS into Oracle Cloud, it turns out to be one of the most successful or smoothest migration to date. So we used Active Data Guard to do the data replication during the migration, so there's no downtime needed to the business. A very small downtime needed for the the Informatica, Cognos, the reporting BI tools. So as you can see, we moved over 50 databases, 60,000 objects, 40 terabytes of data. 5 BI applications and over 500 reports and cubes over from AWS into AWS. And during all this migration process that we got strong support from the Oracle teams, like the product teams from Bruce, Kai, Brian, Sebastian also chipped in on some of the helps, Lee Gates, and also from the CSM teams, the customer success manager that was helping us along the way on anything from getting the credential created, getting the instance provisioned, credential validated, so on and so forth. So, which is a very good experience to have when you are moving into a unknown territory, working with a new, well, we've been working with Oracle for a long time, but this is a new product they have, right? So to work with such a great team to help you along the way, that make us feel much, much better during the whole process. So at the end, so we are live in Oracle Cloud since June. And so far, not a single complaint from performance-wise. And the BI team has been telling us that the performance has drastically improved. They don't have to worry about the reports being delayed or being missed for the day. Actually, it was finished earlier, sooner than we used to have. So from the cost perspective, it's much lower compared to what we have with the Oracle Cloud, with the AWS. And along the way, with the Exadata cloud services on BMCS, that you have tons of new advanced features that we didn't have before. Even though we had the Enterprise Edition license before, we had the RAC before, but we didn't have all the other things like advanced compressions. We didn't have the advanced securities, TDE. We didn't have the lifecycle management, so on and so forth. So there's a long list of features that now we can utilize to help us even further along the way. So we also, now we have a true DR failover strategy. So in AWS, we had, basically it's image copy from one AD zone to another AD zone. So when the primary goes down, basically we need to spin up the new instance and copy the image over and bring it up. So there will be a considerable downtime for that. But with the ADG turned on in Oracle Cloud, there's almost no downtime will be needed during the DR. So the bottom line is that we have drastically improved the employee productivity as well as the customer satisfaction because of the SLAs that we were able to meet and beat by using this solution. So that's the story or journey that we have gone through. Hopefully that's useful to you guys.
So it's always nice to hear when customers have very good experience with the products or the services, in essence, we try to produce. My name is Sebastian Solbach, and I will guide you a little bit about the setup do's and don'ts, because even though You are running in a cloud, and you would expect that everything which you can do is coming from the cloud provider. So why do you have to care about anything setup do's and don'ts at all? Shouldn't it be that the cloud provider is just making sure that everything is running correctly? But you will recognize while going through them, there are some things in the setup process which is really customer responsibility, where we cannot just accept that everything is working out of the box. And I will guide you a little bit through that, as these are the experience which I have received during my time at OCI, being responsible for the Exadata Cloud Service from the side, with issues I have seen with customers which we didn't expect before. So yes, on the service side, there are still things to do where what we can do on our side to protect you from running into the same issues. Until we get that, just a little bit an outlook on things you might be recognizing if you are ever going to use the database cloud service in OCI in whatever form, or even with XRCS, that you can take care of. So, Brian already mentioned the safe harbor statement. I just have it in the presentation as well, just that you know that while I will be talking about the hard facts, so these ones you definitely can take whenever I'm talking about anything in the future, just to make sure you're not doing any buying decision based on that. So what in essence are we talking about when we are talking about the Exadata Cloud Service? So this is the new model in essence. So OceanX started with the X6s, so the hardware generation before. Now, in the meanwhile, if you're going to the Oracle Cloud, you most likely get the next hardware generation. And this is another good thing which you have when you're moving to a cloud provider. Whenever you are starting, in essence, with a new license model which Oracle has, you can make sure to always get the latest release. So you don't have to take an X7 anymore when the next release comes out. You might be choosing the newer ones. So what you get today is a pretty decent hardware, either with 2 nodes, 4 nodes, or 8 nodes, if you really need the workload for a full rack. And here for you, just the numbers on what you can get. Most important, mostly, is the maximum database size which you have, which is really the space for your table spaces and for your database. So this doesn't include things like the fast recovery area. That is already subtracted from that one. But this is the highest size you will recognize when we're talking about the setup, and some future features also, that this numbers might be a little bit lower if you need some advanced functionalities like sparse cloning on an Exadata, which you might know from on-premise. Brian will talk about that a little bit more. Since you are in a cloud, what is important for you to know is that when you are going to get a cloud service, you in essence are only getting a limit from us. So we will be assigning a limit. We don't do any provisioning, pre-provisioning in the backend for you already. It's really, so to speak, a true cloud. Whenever you decide to spin up, you will be placed on that size of a quarter rack, half rack, or full rack. You essentially only get from us the rights to be spinning up an Exadata. When you do get a cloud service from the beginning, we will not be assigning any Exadata limit to you, because Exadata is quite a big offering, and it's not, even though it's quite affordable, it's not 100% cheap. So the first thing you normally need to do is you might need to open a service request and ask Oracle to provide you such a limit that you can start these services. And there already the first things are starting where you have to think about. So how do you want to set it up? Do you have a disaster recovery inside the region? Do you want to have disaster recovery across regions? So where do you want your limits to be? And in essence, you might be deciding that you would like, well, each OCI region has 3 availability domains. So you might already be thinking, I would like to have one in 81 and one in 82. Now for Exadata, the resources are not as plenty as compute resources, especially if you go a half rack or a full rack. You essentially will recognize that often we are the ones deciding which AD you go to, because it might not be that in your AD1 you will get a full rack as of today. Now, quarter racks, we are pretty flexible actually. So there we normally let the customer decide where they want to go to. On a full rack, it's normally you should asking us before. And I already had some customers running into the issue. They were setting up everything, networking, compute, already started, and then they thought, oh, we also need an Exadata. So requesting an Exadata limit, and then we had to tell them, I'm sorry, but in Frankfurt at that time, I didn't have quarter racks in one AD because that was all half and full racks. So I had to tell the customer, nice thinking, but sorry about that, but it has to be 81 or 82. Which was a little bit unfortunate for the customer at that time. Now with X7, this got better. Hardware is definitely getting better. But the same thing, when we are starting new region, we will make sure that the Exadata service is available, but it might not be in all ADs in the same shapes which you might be needing. Which comes to the next point, in essence. If you have seen the announcement of the new Exadata X7 cloud service, what is really interesting, we removed some things which makes the new hardware generation of Exadata cheaper than actually the X6. Because what we removed was the minimum OCPUs. So in essence, today you can decide to spin up an Exadata with just 4 OCPUs. So really reducing your cost for the database licenses to be 4 OCPUs. Now, please keep in mind that an Exadata has some infrastructure running, so you probably don't want to spin up an Exadata with just 2 OCPUs per node, because that might not leave you enough performance for your database workloads, since you spend something for the infrastructure, the grid infrastructure running on there. So best practices from my point of view is at least to have 4 OCPUs per node, and then depending on what you do. So also make sure that in the future, you're always looking on sizing for storage capacity, because what we do not provide today, so that's one thing we have to be working on, you don't have an easy way to go from a quarter rack to a half rack or to a full rack. Because as I told you before, you will be placed on a quarter rack, and if you decide a half rack, that will definitely be a different rack, because the other quarter racks will be used by other customers most likely, so we don't even have the capability to grow you in line, which means you need to transfer your data, which comes back to the point, well, it's not a big downtime, set them up, data guard and everything, which we're trying to automate is something which will help you there. After you size the Exadata and you know where to place it, the next one definitely, which is really important when going to a cloud vendor, especially in OCI, is to do your network setup correctly. Because you might want to have a fast way into the cloud, setting up VPN into the cloud with your fast connect provider to get good performance, to extend your customer network. And then you will recognize, okay, for deploying an Exadata, we need at least two subnets. One subnet is needed for the client access. In OCI, for us, it is normally a public network with public IP addresses. But it could also be the totally private subnet. So if you know 3-tier architectures, normally it's not the database which is exposed to the internet. It's the application server which is exposed to the internet. Your database on-premise is running in a totally private subnet. And the same thing you can do with your cloud. So after we have created that capability in OCI to spin up the database service on a fully private subnet, more than 50% of all the installation we have seen were moving to the private subnet because the database, in essence, does need to be exposed to the internet. Please make sure that if you're creating and that is not necessarily a best practice with Exadata itself, but just from that point of view, if you're thinking about you want to go across regions, please don't take the default which we are providing, because the default subnet is a 10.0.0.0. If you want to set up data guard between regions, you can use nice things like VCN peering to connect two networks together. Now, you can think that if both networks are using the same IP address range, you're pretty much screwed. So make sure you include that into your setup. And the other best practices I always like to tell customers, try to really use short names for your subnets, as this will define your host name, and your subnet, and if you really specified long names there, you might hit an issue on deployment later, because we in essence only allow you that your host name is 13 characters and your whole full domain name is 63 overall. And if you choose subnets with very long names, it might not, you might be ending up having an issue then deploying the Exadata cloud service. And that's nothing we can prevent you on, because creating the VCN is nothing we control from the database side when you're creating the Exadata on a later step. So what is the normal deployment models we see when we see VCNs? And as I said, we are seeing more and more that the whole database service is running on a fully private subnet. So the client is a private subnet where it is only accessible via the application server or from your on-premise network. And the backup itself is also a private subnet. And then you have to know that the object storage is a service which normally has a public endpoint. So how do we reach the object storage to doing the backup, which we standardly do on an Exadata, if you are just on a private subnet? What you need and what we launched a few months back was the service gateway. And there is, however, one other thing which you can see here with the NAT gateway, that for operating system updates, you need access to a YUM server, which is clearly not the object storage as of today, but it's a YUM server running within the OCI data center. And you need to have a NAT gateway to reach that. We will in future make it possible to reach that YUM server also through the service gateway. Then this requirement falls away, but at that moment, that would be the point. Now there's one setup which we probably don't recommend, is that your client subnet is private and your backup subnet is an internet accessible. That probably doesn't make sense anymore after we launch the service gateway. On setting up, that's also a thing which actually comes from the networking. Make sure you're using separate security lists while deploying an Exadata cloud service on the subnets, because you can't add security lists later, and it's a lot easier if you have made it, well, it's more fine granular to assign security controls to subnets if you have multiple security lists than just one default security list, which might screw you up a little bit. So after we did all the prerequisites, how can you deploy an Exadata? So yes, definitely you can just take the console and just easy way, but I see more and more customers essentially tending to deploy the Exadata DB systems with Terraform. And there is a session on Thursday where someone will show you how you can deploy an Exadata with Terraform. I just made all the Terraform script with him together, which might be quite interesting for you if you're interested in how you can using Terraform. And that's also interesting to see how you do upscale and downscale, because that's also possible in Terraform. You just changing your Terraform deployment, say apply, and he will automatically scale up and scale down in the backend. What functions do we provide today? It's not a lot. So you still have to go onto the box to do a lot of things like backups. What we provide today is create terminate of an Exadata, clearly scale up, scale down, and we provided the capability to create additional databases. These will be CDBs, so additional container databases in 12.1, 12.2, 18c, and 19 in the future. But we don't let you create additional PDBs. If you want to use additional PDBs, it's still on the box, SQL, create PDB, standard statement. This is one information you don't find in any documentation, but if you're ever going to deploy an Exadata, please keep in mind that the standard launch time of an Exadata is not as fast as a compute instance, which is up and running in 5 minutes. It takes a little bit time until you get through all the configuration. So for a quarter rack, it's taking approximately 4 days, for a half rack, approximately 6 days, and for a full rack, approximately 8 days. What is really interesting is, though, if you are terminating your service, we are doing a secure erase. So we make sure there's no customer data on there. Unfortunately, that takes 4 days.
Hours.
Secure erase?
Hours. 4 hours.
4 days, up to 4 days.
The first thing launched 4 hours, 6 hours, 8 hours, not 4 days, 6 days, 8 days.
No. Okay, just to make this clear, launch is hours,
Yes.
secure is days. Thanks for the pointing out. So the main reason I mentioned that is termination takes so long. It's not if you terminate, it's away. You don't have to pay for it after you terminate it. We just have to recycle that in the backend, so that's Oracle problem. However, if you are, for example, running on a full rack, and I told you before we don't have so many full racks, what will happen in essence is that you are terminating the service, you simply then can directly launch the next create and get what is happening. That create will not be finished in 8 hours, it will wait. It will wait to get the resources back that we have a full rack again available. And that might take a little bit time. So if you ever have these kind of things, there is a way to delete that cluster without secure arrays. You just need to create a service request and we can terminate the cluster without secure. This is especially interesting. If you didn't follow my best practices to set up your VCN and you deployed your Exadata full rack and you recognize after 1 week, oh, I screwed up on the networking, then, and you haven't have any sensible user data on there yet, maybe it's a good idea to reach out to us that we are terminating the service for you in an hour, then you can directly relaunch your full rack without having to wait until the secure arrays is done. Some things we definitely have to work on. This is already catched that you shouldn't be using system in the API. We didn't catch that at the first, so we went into an issue. One thing which is still there, the compute instances allow you to specify multiple SSH keys on launch. We don't for the Exadata Cloud Service as of today. So make sure to just include one SSH key. And another important fact that's more on the runtime than later, if you're ever going to spin up multiple databases, one thing we still don't do, even though we provide you the capability to launch multiple databases on an Exadata Cloud Service, you still might want to look at the box how your huge pages is configured, that you make sure all the database is running in huge pages. So yeah, you see there's still some kind of improvements to be done, but on the other side, you have root access to the box. One thing which is really important, what I like to mention, because it seems to be, even though you are running in the cloud, the Oracle database is still an Oracle database. It doesn't change just because you are running in the cloud. And whoever has worked with an Oracle database does know that the most important thing when connecting to a database as an application, so not as the DBA, is please use an application service. Because you can define a lot of things when we have nice features in there. For example, there is a feature called application continuity, which in essence allows you to do rolling patching on an Exadata without any downtime for your applications. You just need to use application continuity for this. There's a whole lot of sessions about application continuity on the open world, so just look at that. But just to point out, remember these kind of things. So if we have such a service, how do you connect to an Exadata Cloud Service? Same thing like on-premise. If you are in your VCN, what you would be using is the scan, the single client access name to access that. And the only thing you might have to do additionally is to open the security list for 1521 in your VCN that you can access the cloud instance itself. And that is also the recommended way to access the Exadata Cloud Service. So within your VCN, yes, you can access it from a public network, but that is in the presentation, which I will give you to download. You will see another slide where you can access how you can access from a public IP, but that is definitely not the recommended way because you don't have scan when coming from a public IP. You are essentially just accessing the host. So where is the advantage of running the Exadata Cloud Service versus an Exadata on-premise? Oracle takes care of a few things like patching from the infrastructure. So we take care patching the cells, we take care patching the InfiniBand stack, we take care patching the server. The things which you are responsible for, unfortunately today not in control plane, that's definitely something we have to work on, is you are responsible for your OS itself. So the operating system, it's your responsibility to upgrade. It's your responsibility to upgrade the grid infrastructure and the database, which is good, because on the database side, you mostly don't want to be on the latest release. However, we essentially, from compliance perspective, are required to patch these servers every 3 months. So every 3 months, you will get a notification from us telling you, oh, we need to install the latest security patches on the underlying infrastructure, which will be done on your database hosts rolling. Coming back to my first point, please configure a service, make sure you use application continuity, then this whole rolling patching will not affect you. If you don't, like I had a customer who installed a batch job onto a single node, we did the rolling patching, we killed the batch job, so that was not very fortunate. That you know what's going on when we do the patching. There is another component which will automatically be pushed by us, which is an agent. So we changed, if you ever have known Exadata on OCI Classic, we made a huge change for the Exadata cloud service that we now have an agent running on that box. The agent itself is today just responsible for creating additional databases. But all other functionalities like patching and everything, that will be directly integrated into that agent running on the box. And that agent, in essence, we have a direct communication path. It's a REST-enabled agent. You can reach it. It has its own log files, which can be found under opt-org DCS, where you can really investigate on what is the agent doing. Now, if you want to be, if you don't want that, you could potentially kill the agent. I'm not recommending that, because you will lose all the functionality which we are providing in the cloud. But if you're saying, no, I don't want to have this agent running, you could potentially do that. Please don't, because you will lose all the capabilities. One thing which customers do not know, you get a full cluster stack. So what each Exadata or even each compute instance in OCI has is a metadata service, which you can always query. You get information about the VNICs, about the IP addresses assigned to that Exadata, and you can use this because you know you have a full running cluster stack on there. So if I'm taking the example of the batch job I just mentioned, you could have integrated that batch job into the clusterware to automatically fail over to another node. And that, in essence, is a thing you can also do on an Exadata box yourself. So it's a full stack. We provide the capability to add additional IP addresses to that. The only difference to on-premise, like you used to use it on-premise, on-premise, on a cluster stack, you just needed to add the virtual IP address, and that was all you needed to do. Now, in the cloud, you need to do one thing more. You have to tell our virtualization stack, the cloud infrastructure, that you are now assigning an additional IP address to that Exadata box. And this, in essence, is something which is quite easily done via an API call, which you can do, and then you can have multiple resources, multiple IP addresses, not just like the Exadata was deployed before. So having said that, I'm turning over to Brian now, who will tell you a little bit about the future coming and about one really other important aspect, because what we provide with an Exadata cloud service today is you get a full Exadata, you get root access, which is nice, but it also has some challenges.
Thank you. So I have very short time, and we'd like to get some questions at the end of this, so I will be expedient with this. So you have root access, and that's great and all, and there are APIs that go along with this. So there are many APIs that you can use at the OS level, such as Database as a Service API, which is for creation of your databases, Database as a Service CLI, which you have a lot of lifecycle functions for. Exa CLI, anyone here an Exadata owner? few of you. Access CLI is basically a wrapper for cell CLI. So metrics about your Exadata and the cells and looking at them and getting information, a little bit on IORM in there. And lastly is the backup API, a backup API for backup and recovery. So let's talk about where this is going. So what it's going to come down to is all those APIs are going to be via the agent, because we want this to be a service. We don't want it to be infrastructure. So our long-term goal on this is to get you out of root, to remove root, to get you out of the OS, to be able to do all these functions: patch, backup, automatic data guard, creation of the database, database lifecycle management, PDB management, all that either through a UI or through an API. So you can hook this into an existing provisioning system, whether you're ServiceNow or Terraform, or just use the UI and be able to use it through there. So we want to make this extremely easy, where if you want to patch a database, it's just one click and the database is patched. Now you can do that today, but make it even easier that, creation of the database, deletion of the database, and lifecycle of that database is all through a UI or through an API. So TDE management, key rotation, all that exposed for you to use either, again, through the APIs that we have or through the UI. So our long-term vision, as I keep repeating, is going to be more of a service level Exadata. So getting you out of that OS, getting you out of the weeds, getting you out of an area where one wrong command could basically be trouble, to a service level where you go in and you basically command what you want to do with this Exadata via the UI, or as I said, via an API. Or if you are on the OS, be able to do these functions through a single command line as the Oracle user instead of being root. So we just want to make this easier. We want to make this thing very easy to maintain, to manage, to patch, and keep it the life cycle of it. And as we do this, as we make this easier, hardware generations, going from an X7 to an X whatever, it's going to be a single click. We'll just create those databases on there with DataGuard, and when it's time, you'll fail over, and now you'll be on X whatever. So it's all about making this easy, making the future easy, and getting you on the Exadata platform, as you heard from Jeffrey, where it is, in essence, the best place to run your Oracle database. All right, well, thank you very much. Have a great night.